Reading passage 3, you should spend about 26 minutes on questions 27 to 40, which are based on reading passage 3 below. It has been called the holy grail of modern biology, costing more than pound 2 billion pounds. It is the most ambitious scientific project since the Apollo program that landed a man on the moon, and it will take longer to accomplish than the lunar missions, for it will not be complete until early next century. Even before it is finished, according to those involved, this project should open up a new understanding of and new treatments for many of the animals that afflict humanity. As a result of the Human Genome Project, there will be new hope of liberation from the shadows of cancer, heart disease, autoimmune diseases such as rheumatoid arthritis, and some psychiatric illness. The objective of the Human Genome Project is simple to state but audacious in scope: to map and analyze every single gene within the double helix of humanity's DNA. The project will reveal a new human anatomy, not the bones, muscles, and sinews, but the complete genetic blueprint for a human being. Those working on the Human Genome Project claim that the new genetical autonomy will transform medicine and reduce human suffering in the 21st century. But others see the future through a darker glass and fear that the project may open the door to a world peopled by Frankenstein's monsters and disfigured by a new eugenics. eugenics. The genetic inheritance a baby receives from its parents at the moment of uh, conception fixes much of its later development, determining characteristics as varied as whether it will have blue eyes or suffer from a life threatening illness such as cystic fibrosis. The human genome is the compendium of all these inherited genetic instructions written out along the double helix of DNA are the chemical letters of the genetic text. It is an extremely long text, for the human genome contains more than 3 billion letters. One on the printed page, it would fill about 7,000 volumes, yet within a little more than a decade, and the position of every letter and its relation to its neighbors will have been tracked down, analyzed, and recorded. Considering how many letters there are in the human genome, nature is an excellent proofreader, but sometimes there are mistakes. An error in a single word or gene can give rise to the crippling condition of cystic fibrosis. The commonest genetic disorder among Caucasians. Errors in the genetic recipe for homoglobin and the hemoglobin and the protein that gives the blood its characteristic red color and which carries oxygen from the lungs to the rest of the body give rise to the most common single gene disorder in the world, thalassemia. More than 4,000 such single gene defects are known to afflict humanity. The majority of them are fatal. The majority of victims are children. None of the single gene disorders is a disease in the conventional sense for which it would be possible to administer a curative drug. The defect is pre-programmed into every cell of the sufferer's body, but there is hope of progress. In 1986, American researchers identified the genetic defect underlying one type of muscular dystrophy. In 1989, a team of American and Canadian biologists announced that they had found the site of the gene which, when defective, gives rise to a cystic fibrosis. Indeed, not only had they located the gene, they had analyzed the sequence of letters within it and had identified the mistake responsible for the condition. At the least, these scientific advances may offer a way of screening parents who might be at risk of transmitting a single gene defect to any children that they conceive. Um, Fetuses can be tested while in the womb, and if found free of the genetic defect, the parents will be relieved of worry and stress, knowing that they will be delivered of a baby free from disorder. In the mid 1980s, the idea gained currency within the scientific world that the techniques which were successfully deciphering, deciphering, deciphering disorder related to genes could be applied onto a larger project if science can learn the genetic spelling of cystic fibrosis. Why not attempt to find out how to spell human? Momentum quickly built up behind the Human Genome Project and its objective of sequencing the entire genome, writing writing out all the letters in their correct order. But the consequences of the Human Genome Project go far beyond a narrow focus on diseases. Some of its supporters have made claims of a great extravagance that the project will bring us to understand at the most fundamental level what it is to be human. Yet many people are concerned that such an emphasis on humanity genetic constitution may distort our sense of values and lead us to forget that human life is more than just the expression of a genetic program written in the chemistry of DNA. If properly employed, the new knowledge generated by the Human Genome Project may free humanity from the terrible scourge of diverse diseases. But if the new knowledge is not used wisely, it also holds the threat into creating a new forms of discrimination and new methods of oppression. Many characteristics, such as height and intelligence, result not from the action of genes alone, but from subtle interaction between genes and the environment. What would be the implications if humanity were to understand with precision the genetic constitution which, given the same environment, will predispose one person towards a higher intelligence than another individual whose genes were differently shuffled? Once before in this century, the relentless curiosity of scientific researchers brought to light forces of nature in the power of the atom, the mastery of which has shaped the destiny of nations and overshadowed all our lives. The Human Genome Project holds the promise that ultimately we may be able to alter our genetic inheritance if we so choose. But there is the central moral problem. How can we ensure that when we choose correctly, that such a potential is a promise and not a threat? We need only look at the past and to understand the danger.